the particular integral of f of d into y is equal to phi of x, where phi of x is equal to e power ax into v. In the previous methods, we have seen to find the particular integral of a function of x individually. So here we are going to look after the function phi of x is equal to e power ax into v. If the e power ax and v is a function of x are multiplied together, then the particular integral of this type of functions ought to be found. So here where a is a constant and v is a function of x. So to find particular integral of 1 by f of d into e power ax into v, the working rule is first step is to take your e power ax to the left hand side of 1 by f of d by replacing d by d plus a. Means 1 by e power ax into 1 by f of d plus a into v. Now the second step is 1 by f of d plus a into v is to be calculated by the previous methods which are discussed. Means depending upon the function of x. Suppose it is trigonometric function, we have to apply the procedure to find the particular integral to find for trigonometric function. If it is an exponential function, we have to apply for exponential function. If it is a binomial, we have to apply the procedure for binomial function. Hence, the particular integral of 1 by f of d into e power ax into v is equal to e power ax into 1 by f of d plus a into v. So, the first problem solve d square plus 1 into y is equal to e power x into cos x. So the given differential equation is d square plus 1 into y is equal to e power x into cos x. As discussed in the previous lectures, the solution is always given by y is equal to complementary function plus particular integral. So to find complementary function, the auxiliary equation is to be found, which is f of m is equal to 0, means m squared plus 1 is equal to 0. So this implies m square is equal to minus 1, implies m is equal to plus or minus I. This plus or minus I can be written as 0 plus or minus I, means the roots are imaginary. If the roots are imaginary, the complementary function is given by e power 0x into cos x, c1 cos x plus c2 sin x, depending upon our alpha and beta values. So therefore, complementary function is equal to c1 cos x plus c2 sin x. Now to find particular integral is equal to 1 by d square plus 1 into e power x cos x. So as we discussed in the previous working rule, the d should be replaced by d plus 1, since the coefficient of x in the exponential function is 1. So replace d by d plus 1, and you have to get your e power x to the left hand side of 1 by d square plus 1 in the same step. So this is equal to e power x into 1 by d plus 1 whole square plus 1 into cos x. So this is equal to e power x into 1 by d square plus 2d plus 1 into cos x. So this is equal to e power x into 1 by d square plus 2d plus 2 into cos x. So as we have already seen the procedure to find the particular integral for trigonometric function cos x. So in this procedure, you have to replace d square by minus a square. You should not touch your d. So this implies you have to replace d square by minus 1 for this problem, since the coefficient of x in the trigonometric function cos is 1. So this is equal to e power x into 1 by minus 1 plus 2d plus 2 into cos x. So this is equal to e power x. Now 1 by 2d plus 1 into cos x. Now we are not bothered about our exponential function e power x. This will be done only by replacing d by d plus 1. Then you can shift your e power x or e power ax to the left hand side of 1 by f of d, and then continue the procedure to find the particular integral of 1 by f of d into cos x, which is nothing but the previous methods which you are discussed. So it's take the linear form 2d plus 1. After taking the linear form, you have to multiply with the conjugate. So multiplying and divide by 1 minus 2d. So it will be equal to e power x into 1 minus 2d by 1 minus 2d into 1 plus 2d into cos x. So it will be equal to e power x into 1 minus 2d by 1 minus 4d square into cos x. Now this will be equal to e power x into 1 minus 2d by 1 minus 4d square into cos x. So again you have to replace our d square by minus a square, which is equal to minus 1. So this is equal to e power x into 1 by 1 minus 2d by 1 minus 4 into minus 1 into cos x. So it will be equal to e power x by 1 minus of 4 minus 1 becomes 1 plus 4, which is equal to 5 into 1 minus 2d into cos x. So this will be equal to e power x by 5 into cos x. You have to multiply your cos x into the inside term. So minus 2d cos x. So this is equal to e power x by 5 into cos x minus 2 into derivative of cos x is nothing but d cos x is nothing but differential operator. D cos x is nothing but minus sin x, so it becomes plus sin x. So therefore, our particular integral is equal to e power x by 5 into cos x plus 2 sin x. So therefore, the solution is, put it as equation 4, substitute 3 and 4 in A, implies y is equal to complementary function plus particular integral. Complementary function we got c1 cos x plus c2 sin x, and particular integral is plus e power x by 5 into cos x plus 2 sin x. So next problem, solve d square minus 2d minus 3 into y is equal to x cube e power minus 3x. So here the given differential equation is d square minus 2d minus 3 into y is equal to x cube e power minus 3x, and this is in the form of f of d into y. F of d into y is equal to q of x. Put it as equation number 1. So the solution is y is equal to complementary function plus particular integral. Keep it as a. Now to find complementary function, the auxiliary equation is f of m is equal to 0, implies m square minus 2m minus 3 is equal to 0. If you factorize this term, it will be equal to m minus 3 into m plus 1 is equal to 0. So this implies the roots are m is equal to 3 comma minus 1. The roots are real and distinct. The roots are real and distinct. So therefore, complementary function is given by C1 e power 3x plus C2 e power minus x. Put it as 2. Next, to find the particular integral. Particular integral is equal to 1 by d square minus 2d minus 3 into x square x cube e power minus 3x. So you have to replace, since a is equal to minus 3, put d is equal to d minus 3 in f of d. So this implies this will be equal to e power minus 3x should be sent to the left hand side of 1 by f of d. So d minus 3 whole square minus 2 into d minus 3 into x cube. So if expand this term, this will be equal to e power minus 3x into 1 by d square plus 9 minus 6d minus 2d plus 6 minus 3 into x cube. So this will be equal to e power minus 3x into 1 by d square minus 8d plus 6 into x cube. So since it is a polynomial here, since x cube is a polynomial, you have to bring your least term to the outside of f of d, which is nothing but constant 6 in this case. So this is equal to e power minus 3x into 1 by 6 into 1 plus d square minus 8d by 6 into x cube. So this will be equal to e power minus 3x into e power minus 3x by 6 into 1 plus d square minus 8d by 6 whole inverse into x cube. So if you apply binomial expansion, by binomial expansion, so this will be equal to e power minus 3x by 6 into, since it is plus inside and minus outside, as we have discussed in the previous methods, 1 plus d whole power minus 1 is equal to 1 minus d plus d square minus d cube plus and so on. So 1 minus d square minus 8d by 6 plus d square minus 8d by 6 whole square minus so on into x cube. So this is equal to e power minus 3x by 6 into 1 minus d square minus 8d by 6 plus d square minus 8d by 6 whole square minus d square minus 8d by 6 whole cube in plus and so on x cube. So since the power of x is 3 here, you have to neglect higher order derivatives. Neglect higher order derivatives from d cube. Higher order derivatives from d cube in the expansion. So this will be equal to, so you have to carefully check the terms, what are we are getting here. So e power minus 3x by 6 into 1 minus d square by 6, minus into minus becomes plus 8d by 6. Now in the whole square I get a square. So d is d power 4. So it is not, it is the higher order from d cube. So you should not take this. Next b square, which is nothing but 64 d square by 16 minus 2ab. Minus 2ab means minus 16 d cube by 36. Minus 16 by 16 d cube by 36 minus, here it is in the form of a minus b whole cube. So a cube cannot be obtained, and 3a square b and 3ab square also cannot be obtained. So left over is b cube, which is nothing but plus 64. So e power minus 3x by 6 into 1 plus t cube into 512 by 216 minus 16 by 36 plus d square into 64 by 16 minus 1 by 6 plus 8d by 6 into x cube. So if you're taking the common terms and simplifying, we got 1 plus d cube into 14 by 9 plus d square by 23 by 6 plus 4d by 3 into x cube. So if you multiplied your x cube inside, it will take the form e power minus 3x by 6 into x cube plus 14 by 9 d cube x cube plus 23 by 6 d square x cube plus 4 by 3 d x cube. So now dx cube value is nothing but differentiating 1 times you will get 3x square, and d square x square is nothing but again differentiating you will get 6x, and d cube x cube is equal to 6. So substituting these values here, you will get this is equal to e power minus 3x by 6 into x cube plus 14 by 9 into 6 plus 23 by 6 into 6x plus 4 by 3 into 3x square. So the sum of the terms cancels each other. So here 6 gets cancelled, 3 gets cancelled, and here it will be 2 by 3. So e power minus 3x by 6 into x cube plus 28 by 3 plus 23x plus 4x square. So our particular integral is equal to e power minus 3x by 6 into x cube plus 28 by 3 plus 23x plus 4x square. So substituting, now we found both complementary function and particular integral. So substituting complementary function and particular integral in the solution, A, we get y is equal to c1 e power 3x plus c2 e power minus x plus e power minus 3x by 6 into x cube plus 28 by 3 plus 23x plus 4x square. So this gives the solution of the given differential equation. Next problem, solve y double dash plus 2y dash plus 5y is equal to 4 e power minus t cos 2t, and the conditions are y of 0 is equal to 1 and y dash of 0 is equal to 1. Sorry, y dash of 0 is equal to 0. These are called as initial value problems. Why this initial value conditions will be given means you have to find the constants c1 and c2 which are obtained in the complementary function using this initial conditions. Now we are going to look after the problem involving this type of initial value conditions. So here the given differential equation is y double dash plus 2y dash plus 5y is equal to 4 e power minus t cos 2t. Now actually this is not given in the form of f of d into y. So you have to first write this as f of d into y, which implies t square plus 2d plus 5 into y is equal to 4 e power minus t cos 2t. Now this is in the form of f of d into y is equal to q of x, where the solution is y is equal to complementary function plus particular integral written as a. Now to find the complementary function, the auxiliary equation is f of m is equal to 0. F of m is equal to 0 implies m square plus 2m plus 5 is equal to 0. So for this equation, it is not possible to factorize. So you will apply the formula for minus b plus or minus root of b square minus 4ac by 2a. Minus b plus or minus b square minus 4ac by 2a. So this is equal to minus 2 plus or minus root minus 16 by 2. So this is equal to minus 2 plus or minus 4i by 2. So this is equal to minus 1 plus or minus 2i. So therefore the roots are imaginary. Therefore complementary function is given by e power alpha x, which is nothing but minus x into c1 cos beta x, which is nothing but cos 2x plus c2 sin beta x, which is nothing but sin 2x. So this is nothing but our complementary function. Next, to find the particular integral, particular integral is equal to, so here it is t not x, since the independent variable is t here. So particular integral is equal to 1 by d square plus 2d plus 5 into 4 into e power minus t cos 2t. Since 4 is a constant, you can bring your 4 outside. So 1 by t square plus 2d plus 5 into e power minus t cos 2t. So since a value is equal to minus 1, put d is equal to d minus 1 and bring your e minus t to the left hand side of 1 by f of d, which is equal to 4 into e power minus t into 1 by d minus 1 whole square plus 2 into d minus 1 plus 5 into cos 2t. So this is equal to 4 into e power minus t 1 by d square minus 2d plus 1 plus 2d minus 2 plus 5 into cos 2t. This is equal to 4 e power minus t 1 by d square, here minus 2d plus 2d gets cancelled, minus 2 plus 1 minus 1 plus 5 minus plus 4. So plus 4 into cos 2t. So since we have discussed in the previous procedure, since here a is equal to 2, put d square is equal to minus a square, which is equal to minus 4. So if you substitute minus 4, it becomes 0. So since f of minus 4 is equal to 0, so this implies 4 into e power minus t into multiply t in the numerator and differentiate d square plus 4 with respect to d. Then it will be 2d into cos 2t. So since we cannot do anything with d, you have to multiply d with the numerator as well as in the denominator. So it will be 4 into e power minus t into t into d by 2d square into cos 2t. Now we place d square by minus a square, which is equal to minus 4. So this will be equal to 4 into e power minus t into t into d by 2 into minus 4 into cos 2t. So here minus 4 gets cancelled. So it will be equal to minus e power minus t by 2 into t into d cos 2t. D cos 2t is nothing but differentiation of cos 2t with respect to t. So it will be minus e power minus t by 2 into t into cos is nothing but minus sine 2t into 2. Because in differentiation the constants associated with the variable gets multiplied. So it will be equal to e power minus t by 2 into t into sine 2t into 2. So 2 gets cancelled each other. So our particular integral is equal to t into e power minus t into sine 2t. Now substituting the particular integral as well as the complementary function in the solution, you get the solution as y is equal to e power minus x c1 cos 2x plus c2 sin 2x plus t into e power minus t sin 2t. Now put it as equation number B. So this is nothing but your y of t. So y of t is equal to e power minus t c1 cos 2t plus c2 sin 2t plus t into e power minus t sin 2t. So to find y dash of t, differentiate this with respect to t. So this will be equal to e power minus t into u into derivative of v, which is nothing but minus 2c1 sin 2t plus 2c2 cos 2t. So u into derivative of v is over minus e power minus t into c1 cos 2t plus c2 sin 2t plus here it is uvw, derivative of uvw, uv into derivative of w plus uw into derivative of v plus vw into derivative of u. So it is equal to t into e power minus t into derivative of sin 2t is nothing but 2 cos 2t plus t into sin 2t into derivative of e power minus t is minus e power minus t plus e power minus t into sin 2t into derivative of t is 1. So after simplification we get like this, y dash of t is equal to e power minus t into minus 2c1 sin 2t plus 2c2 cos 2t minus e power minus t into c1 cos 2t plus c2 sin 2t plus 2t e power minus t cos 2t plus minus t into e power minus t sin 2t plus e power minus t sin 2t. Now put it as equation number C. So given initial conditions are y of 0 is equal to 1 and y dash of 0 is equal to 0. Put as equation number 4 and 5. Now substitute 4 in B, which implies put t is equal to 0 in B. So y of 0 is equal to 1 implies you have to substitute in the place of t with 0. So y of 0 is equal to e power 0 into c1 cos 0 plus c2 sin 0 plus 0. All the terms here become 0 and it is equal to 1. So this implies we get, since e power 0 is equal to 1, c1 is equal to 1. So we obtain the constant c1 here and substitute 5 in c. Implies you have to put t is equal to 0 in c. So y dash of 0 is equal to e power 0 into c1 2c1 sin 0 plus 2c2 cos 0 minus e power 0 c1 cos 0 plus c2 sin 0, and here this terms become 0, this terms become 0, and plus e power 0 into sin 0. So this is equal to 0. So from this it implies, since sin 0 is equal to 0, cos 0 is equal to 1, it becomes 2c2, and here it is minus c1 is equal to 0. So this implies 2c2 is equal to c1. Implies c2 is equal to c1 by 2, which is equal to 1 by 2. So therefore our c2 value is equal to 1 by 2. So substituting c1 and c2 values in B, you get the solution which are not having any constants. This is called as initial value problem. So c1 e power minus t into c1 value is 1 cos 2t plus 1 by 2 sin 2t plus t into e power minus t sin 2t. So this gives the solution of the given differential equation. The only difference between the previous problems and this problem is here initial value conditions are given, which are used to find the constants of the given obtained solution of the differential equation.